Ph261 Ch4 Problem number 5. A projectile is fired horizontally from a gun that is 76 meters over the ground with a speed of 250 meters per second. So what we are given is we have a delta y of 76 meters, and we have an initial velocity in the x direction, so v0x of 250 meters, and we're asked how long does the projectile remain in the air. So we know our projectile motion equations, then we know we know that delta y equals v0 y t minus 1/2 g t squared. Now, since this is 0, this whole thing is 0. So we are left with 76, which is delta y, equals 1/2 9.8 t squared. 1/2 9.8 is 4.9. Did not need a calculator for that. So if we divide this by 4.9, 76 divided by 4.9, that's 15.51 equals t squared, square root both sides, and t equals 3.38. So that's how you solve A. And I think we're going to be running out of space, so I am going to get rid of this. Just going to leave the time there. So now it's asked, at what horizontal distance from the firing point does it strike the ground? So we go to our projectile motion equations for x, and we have delta x equals, it does not equal that, equals v0x times t. And we have t equals 3.38, and we know v0x, so delta x equals 250. This is supposed to be meters per second. 250, oh no, everything's messing up. 250 meters per second times 3.38. And if we do that, then our delta x, actually I will put this over here. Delta x equals 984 meters per, well, just meters. And this is seconds. And then it's asking us for C, it asks, what is the magnitude of the vertical component of its velocity as it strikes the ground? So we see here in, let's see, the projectile equations, or projectile motion equations, we have one which is Vy equals V0y minus gt, okay? And again, we know that this is 0, so velocity final in the y direction is equal to negative 9.8 times 3.38. And if we do that, we get velocity final y equals 39. That's 39 meters per second. And that is how you do this problem.